In this video, we're going to take a look at some examples of special right triangles. In the previous video, we learned about the two types of special right triangles, the 45-45-90 triangle and the 30-60-90 triangle. And so this video is just to kind of use that knowledge and practice it a little bit more for those people that want a few more examples. All right, so let's start off with the first triangle that we have. We're going to find the missing side lengths here. Now, whenever you're working with right triangles, you always want to ask yourself, are you working with one of the special right triangles? And so you can always identify when you're working with special right triangles by looking at the angle measures. If you can tell that the angle measures are either 45 and 45 or 30 and 60, then you know you've got a special triangle. Now in this one, it doesn't give us the angle measures, but because we have a 90-degree angle up here, and because the other two angles are marked as being congruent, we can calculate that both of these two angles have to be 45 degrees. So we do have a 45-45-90 triangle. Now, sometimes triangles get twisted, flipped, stretched, things like that. One of the first things you need to do when solving a triangle is identify which side is the hypotenuse. Remember that the hypotenuse will always be across from the 90-degree angle. So in this case, D would be our hypotenuse, which means that the other two sides in the 45-45-90 triangle are just simply legs. Now we already know that the two legs in a 45-45-90 triangle must be congruent. So we can get length C right away. That's because the two 45-degree angles mean that this is an isosceles triangle. Now if we want to solve for D, let's just put the 6 square root 2 into the equation that we know has the relationship between the leg and the hypotenuse. So the hypotenuse of a 45-45-90 triangle will always be equal to the leg times the square root of 2. So since the hypotenuse is the unknown, we'll put D in there. The leg for this triangle is 6 square root 2, and then we're just going to multiply that by square root 2. Now this might seem a little bit odd because the square root of 2 was already in the leg, but that just means that's just a way to describe the length of that leg. And so all we have to do is plug it into the formula and calculate what that would equal. So 6 times square root of 2 times square root of 2, we can do the times square root of 2's together. And so that would give us 6 times the square root of 4. And then we know that the square root of 4 is really just 2. So D would just have to be 6 times 2. So D in this case will be 12. Now, a lot of people think that because there's a square root 2 relationship between the leg and the hypotenuse, that the hypotenuse always has to be written as a square root of 2. But that's not true. If the leg already has a square root of 2 in it, then multiplying that by the square root of 2 will make it come out to just be a nice integer value. Let's take a look at another example. Here we can see that we have a 30-60-90 triangle. All right, so in this example, we're going to have to use the other relationships. And that is that the hypotenuse is 2 times the short leg, and the long leg is square root of 3 times the short leg. Once again, we want to identify where's the hypotenuse, okay? So across from the 90-degree angle tells us that 6 square root of 3 is the hypotenuse. So we can really only solve one side of this triangle to begin with. This would be the short leg and this would be the long leg. And the only equation we have that uses the hypotenuse will solve the short leg for us. So we actually don't really have a quick way to solve or to connect the hypotenuse with the long leg. So let's go ahead and take this equation. The hypotenuse equals 2 times the short leg. Let's plug in 6 square root of 3 for the hypotenuse. And then let's solve for the short leg. In this case, we have to divide by 2. So the short leg will equal 6 square root of 3 divided by 2. Now, the numbers that are outside the root here can actually operate together. So this 6 divided by the 2 would create a 3. So really, the best way to say what the short leg is equal to is just to say that it's 3 square root 3. All right, now that we know what the short leg is, we can solve for the long leg using the other equation. The long leg is equal to the square root of 3 times the short leg. So long leg equals square root of 3 times the short leg, which we solved out to be 3 times the square root of 3. So once again, we have a couple square roots that need to multiply together. So the square root of 3 times the square root of 3 will create the square root of 9. And then we still just have this 3 on the outside. But really, the square root of 9 is 3. So the long leg in this case is just going to be 3 times 3, which equals 9. Once again, we might think that the long leg, since the long leg has a square root of 3 ratio, we might think it always has to have a square root of 3 in its answer, but it's not true. Sometimes the other distances are the ones that have the square root of 3 in it, and when you multiply by the square root of 3, your answer comes out to be really nice. All right, we'll do 2 more examples in this video, and we'll probably go a little bit quicker with these ones. All right, so we're going to try to find all the missing side lengths here, which we can do pretty quickly since we have a 30-degree angle here with a 90-degree angle. That means the other angle here is 60. We would have a 90-degree angle on this side with the 45-degree angle, means that this would also be 45 degrees. Okay, in the 45, 45, 90 triangle, 10 is the hypotenuse, which means that DC is a leg and BD is a leg. So we can solve that one out using the 45, 45, 90 relationship that the hypotenuse is square root of 2 times the leg. So let's go ahead and plug in 10 for the hypotenuse, and let's solve for the leg. We would have to divide by square root of 2. So 10 divided by square root of 2 will be the leg, or DC and BD. But let's go ahead and rationalize that denominator, right? So 10 divided by the square root of 2, we're going to have to multiply that by square root of 2 over 2. So on the top, we get 10 square root of 2. On the bottom, we would get square root of 2 times square root of 2, which would be square root of 4, which we can just write as 2. So the 10 divided by the 2 will give us a nice, simple 5 square root 2 as our answer. All right, so DC is going to be 5 square root 2. That also means that BD is going to be 5 square root 2. Now, we've got side length BD, which exists in the 30, 60, 90 triangle, so we can solve those other two sides, AB and AD, using that triangle. So I'm just in case this is getting a little too complicated here, I'm just going to redraw this really quick. So we have A, B, and D. We just found out that this side length here is 5 square root 2. Now, in this triangle, AB would be the hypotenuse, BD would be the short leg, and AD would be the long leg. So we actually have the short leg. We can use that short leg to solve both of the other two sides. I always start with the hypotenuse since that's the easier one. So for a 30, 60, 90 triangle, the hypotenuse is just simply 2 times the short leg. So that's easy. The hypotenuse of this would be 2 times 5 square root 2. The 2 times the 5 can multiply together, and that would just be equal to 10 square root 2. All right, and then we can also use the short leg to solve for the long leg. So in a 30, 60, 90 triangle, the long leg is equal to square root of 3 times the short leg. So the long leg will be equal to square root of 3 times 5 square root of 2. Now, just like before, we can only multiply things that are in the roots together or things that are outside the roots together, but we cannot mix them together. So in this case, we have 2 square roots that need to multiply together. So the long leg is going to be, the 5 is going to remain unchanged, but underneath the root, the 2 and the 3 will multiply together. And so the long leg's, easiest way to write its value would be 5 square root of 6. So AD is 5 square root of 6. AB would be 10 square root of 2. Notice we have not had to use Pythagorean theorem once in this whole video. We're just doing everything based on these ratios. All right, well, we're going to do one last example just to kind of close this up. I hope this is making sense at this point. And so this example will just kind of drive home those ratios that we're working with here. So in this picture, we've got a 45, 45, 90 that's sharing a side with a 30, 60, 90, kind of like our last example, but maybe in a little bit different orientation. Now, since we have this side length here is 6, let's work with that triangle first. Since that one's a 30, 60, 90 triangle, we're going to label this side as being the hypotenuse because it's across from the 90-degree angle. This side would be the short leg, and the 6 would be the long leg. We know that the long leg is equal to square root of 3 times the short leg. So let's plug in the 6 for the long leg. And let's solve for short leg. In order to get short leg alone, we would have to do 6 divided by square root of 3 to equal the short leg. But let's go ahead and rationalize that denominator. So 6 divided by square root of 3. We're going to multiply that by square root of 3 times square root of 3. So 6 times square root of 3 would be on top, and then square root of 3 square root of 3 times square root of 3 would be square root of 9. But you know what? The square root of 9 is just 3. So this whole thing will simplify down if we do the 6 divided by 3 into 2 square root 3. So for the short leg, I'm going to go ahead and put this 2 square root 3. All right, now we can calculate the hypotenuse. Remember, the hypotenuse and the short leg relationship is pretty simple. It's just hypotenuse equals 2 times short leg. We know the short leg is 2 square root 3. And so the hypotenuse in this case will just be 2 times 2, which is 4 square root 3. All right, now that basically solves everything in that upper triangle. But now let's look at the lower triangle. In the lower triangle, it's a 45, 45, 90, and this time the hypotenuse is actually x. That means that the other two sides in that 45, 45, 90 triangle are the legs. So we know if one leg, this leg here, is 4 square root of 3, the other one must also be 4 square root of 3. And then to get the hypotenuse, we just have to use the 45, 45, 90 relationship, where the hypotenuse is equal to the square root of 2 times the leg. So let's type that leg in there. Hypotenuse equals 2 times, the leg here is 4 square root of 3. Oh, sorry, not 2 times. Square root of 2 times. All right, so square root of 2 times 4 square root of 3. Just like before, roots can multiply by roots. So the square root of 2 times the square root of 3 would give square root of 6, and the 4 would remain on the outside. So x equals 4 square root of 6. The more you practice this, the more you will get used to doing this quickly, and the less work it will take you to get an answer. You might have to rationalize a denominator once or twice, but once you get really good at this, you'll be able to solve one of these questions without writing all of these equations out. But even if you never get to the point where you stop writing these equations, that's okay. The equations will always lead you to a correct answer. It just takes a little bit more time, and that's all right.